Hey, good morning everybody. Welcome to Dev 401, LINQ Confidential. We're going to be taking a bit of a look at how LINQ works. And first thing I want to ask is, who wants to see some PowerPoint? There's a guy that you're in the wrong place, man. I have some slides. Hopefully we won't need them. We're basically going to dive straight into some code and see how LINQ works. So there's a couple of caveats I want to put on this, caveats and requests. Firstly, it's a 400 level session, so we're going to dive into some code. We're going to have a little poke around, poke under some rocks, see what bites us, that kind of thing. It's not going to be an introduction to LINQ, so if you've not used LINQ before, we may dive in a little bit deeply for you. The second thing is, what leads on to that is, I'm really happy to be driven by you guys. I've got a bunch of things that I think are cool and interesting I want to show to you, but if I'm going too fast, or if I'm going in the wrong direction, or if there's something else that you guys want to see, sing out, yell at me, throw things at me, soft things please, it's still pretty heavy. I'm really happy to make this an interactive session, just sort of bounce ideas around, try out code, see what happens. Are we good for that? Awesome, right. So that's enough PowerPoint. Let's get rid of that. Oh, I don't want to see that. That's the wrong kind of code. There we go. This is some .NET 2 code, and you can see we've got. I'm using here just a model that just returns a list of objects, and I can do useful things. I can do useful queries against that model. So for example, I can do a for each in peas.findAll, there's a lovely method on list. I can pass it a delegate, semicolons, squirrely brackets, like that. I've got enough brackets there. And we can do then whatever we want with that thing. So if I run that, then you'll see it's selected the appropriate things from that list. It's done a find all. Everything's good. What happens if I decide I want to program against an interface? Now I've got a problem. Now even though that's an iList, that's a pretty rich thing, I still can't use find all against it. If I had a IEnumerable, that would be even worse. There's almost nothing on IEnumerable. There's only the get enumerator method on that. And what this shows us is we've got a tension here between interface implementers and interface consumers. If I've got an IEnumerable of Penguin, then find all is pretty clearly defined. I can just iterate through that IEnumerable. I can just for each over it and just return all of the things that match the criterion. So find all should surely be a member of IEnumerable. On the other hand, if find all was a member of IEnumerable, then every single class that implemented IEnumerable would have to implement find all, and they would all implement it in exactly the same way. So we've got that tension between consumers who want really rich, capable interfaces with lots of good methods that they can make use of, lots of convenience methods, and interface implementers who want the interface to be very frugal, very minimal, so they don't have to do much work to implement the interface. So how do we resolve that tension? Well, we can do so by using, if we create a bunch of helper methods, for example. So I could implement find all, just as I described. Static IEnumerable of T. Thank you. Wow, we're 5 minutes in and my demos are already going wrong. This is good. Find all of T, and that's going to take a IEnumerable of T source and a function from T to Boolean, which is going to be the predicate. And the implementation of that is obviously pretty trivial. We just talked about it. For each t obj in source, if predicate of obj yield return obj. So now I can do a find all of p's with that delegate, and now that compiles. In practice, of course, I'd move this off into a helper class rather than having it built in there. So if I go into enumerable helpers, I can pop that in there. This does make my calling syntax a little bit less convenient. Let's just get rid of that from here, because I've now got to write enumerable helpers dot find all. On the plus side, this also helps me with separation of concerns. So suppose that I don't want to just print all those things out. I want to get the count of them. Now, I could have a count variable here, and I'd do a plus count, and then I'd do a console.writeLine count. But now I've kind of got my iteration logic mixed up with my business logic. The job of this method is to dial P for penguin. I don't know what that means, but I'm pretty sure it doesn't involve manipulating low-level integer variables. So what I'd like to do is move that count stuff out into a helper method. Well, that's not too difficult to do. Let's have a look. Let's create a getCount method. And that means that I can now say int count equals enumerable helpers dot get count of enumerable helpers dot find all on p's, and we'll need a whole lot more brackets until it stops complaining at us, and then we're good to go. So if I run that, it doesn't compile because I've got too many brackets or too few. It was too many brackets. There we go. So if I now run that, then you can see it's got that count coming out. On the other hand, this is still not a really friendly interface because things kind of read the wrong way around. What I'd really like to be doing is saying, find all of the penguins that meet these criteria and count them. With the static methods, we can't do that. If only count and find all were member methods on IEnumerable, we'd be able to do that. We'd be able to do something .find all, that would return an IEnumerable. We could do a .count or .getCount on that. But then we run into that tension that we talked about earlier. The way that C#3 and Visual Basic 6 solve this is with a technique called extension methods. And in C#, the way you create something as an extension method is to put this against the first parameter. So if I put a this on these things, that allows me to call these in a different way. I can still use that static method syntax, but I can also go like that. So I can use it as though it were a member. Sorry, dot get count. And the nice thing is that resolves that tension. I've now got a friendly way of writing this where everything looks like member methods, everything is composable, and yet I've not had to bloat the interface. I've not had to put additional requirements on people who implement the IEnumerable interface. So by doing this, I'm beginning to build up a rich but natural library of capabilities of things that IEnumerable can do, even though IEnumerable itself remains minimal. We can now do lots and lots of cool stuff with it. There is one more thing that looks a little bit verbose there. We've got this enormous, great anonymous method here, and really a lot of these words are not adding any value. We know it's a delegate because it's appearing in find all. We know it's about penguins because we know what's being found. We know it's going to return something. So C#3 again allows us to use a more compact syntax, which they call lambda notation. And that does exactly the same thing. but we've saved quite a lot of space. It can be read as p go to p.name starts with p. It's just a little bit more compact, a little bit more easy to write. So it makes that chaining together of these operators kind of convenient, easy to read. And if we run that, we're going to still end up with, of course, exactly the same result. Now, I've explained lambda expressions in terms of making things more compact. There's actually more going on in the secret world of lambda expressions, and we'll see why that becomes important later on. Does that all make people familiar with the extension methods thing? Excellent. Okay. The other thing I want to mention as kind of one of the foundational considerations for LINQ is type inference. And again, this is something that was brought in C# 3 and Visual Basic 9. And here, life is pretty good. We're dealing with inumerables, and we can write things out pretty easily. So if I start jumping into a LINQ query, I can re-express what I already had as a LINQ query. I can return it to an inumerable of penguin, and everything's happy. What now if I start using more complex operators? For example, what if I use the group by operator? Well, group by returns an enumerable of I grouping of int of penguin, which is a pretty snappy name for a type. And I don't know about you guys, but I don't fancy typing that every time I want to use one of these things. Unfortunately, that is actually the least of our problems, because now, what if I decide I want to project certain information out from the penguin? I just want to pull out the name and the age. Well, what am I going to put on the left-hand side here? What is the name of that name and age type? Well, it hasn't got a name. There is nothing I can write on the left-hand side. There is no type name I can write on the left-hand side that will make that compile. So C# solution to this, and Visual Basic uses a similar syntax with the dim keyword. C# says, if you just put var there, I'll work out what type it is. I will look at the thing on the right-hand side, and I will declare the thing on the left-hand side to be the correct type for that. Even if that type hasn't got a name, the compiler will make up a name for it internally. I can't use that name, but the compiler can put the same name on both sides, and that makes everything happy. So again, type inference, something that we're all familiar with, yeah? All good? Excellent. Okay, so that's kind of all I really wanted to cover in terms of the ingredients that kind of make up the foundational to LINQ. And I now want to move on to talk about how the compiler actually compiles LINQ queries. So we've seen here, we've got some special syntax in the C# language, and we've got something pretty much identical in the Visual Basic language. What happens when the compiler sees that? How does it get from there to something that will actually work? Well, the simplest thing to do is always to have a look at what's going on the inside. And for that, we can use a tool called Reflector. Are people familiar with Reflector? Most people? Anyone not familiar with Reflector? Okay. So Reflector, just for people who are not familiar with it, Reflector is a tool that can look at a compiled assembly, including the .NET Framework assemblies. It will look at the bytecode, and it will try to reinterpret that bytecode and figure out the original C# or Visual Basic constructs, the original code that would have compiled to that. So if I take a look in here, if I look in my program class, I've got my dial-p for penguin LINQ method, and I've turned off. Reflector is actually unfortunately too clever for this demo. It can actually reconstruct LINQ expressions now, which I really don't want it to do. But let's look at what it's actually done here. So we had in our original code this where syntax. And what's that become compiled down to? It's come compiled down to that same source, .where. So there's an extension method called where on IEnumerable. And that where operator in the LINQ clause has been translated to the .where extension method, and that body of the where clause has been turned into a delegate, which is this bit. Can people see that disassembled code okay? People at the back, you're all right with that? I'll see what I can do. Appearance, let's try appearance. Here we go. Browser font. Oh, that might be too much. Oh, fantastic. Wrong guess, guys. No, sorry about that. Let's put that down to, let's try that. Okay, no worries. Sorry about that, chaps. Okay, so you can see it's translated that where operator into the .where extension method. And in fact, this is a very naive transformation. The compiler isn't actually thinking about the semantics at this point. It's not thinking about what kind of stuff we've got, about what those methods right resolve to enumerable.where or whatever. All it's doing is a really kind of dumb translation of, well, I'll take that keyword and I'll translate that to .where. It doesn't even need to be an extension method. It doesn't even need to be an IEnumerable. Let's take a ludicrous example, because ludicrous examples are good. Let's imagine we've got a class called clothing. And let's furthermore imagine that it's got a wear method on it, because you wear clothing, right? We're getting there. So let's have a public clothing wear. And do I need anything? I need a func from clothing to bool, because that's the contract of wear. And what am I going to do in that? Let's just pull this down. So I know this is obviously a major concern for tech ed employees. Let's get rid of that. We don't want the extension method. We're not interested in extension methods. So we'll return this. And that's going to be f of this. So what happens when we now run a LINQ query over this? I mean, clearly it's ludicrous, because this is not an IEnumerable. It's not a queryable object in any way, shape, or form. Does the compiler complain? It does not. It's perfectly happy. It just, that where clause just gets translated to call into the where method, or it gets translated into .where, which in turn resolves down to a call to the where method, which just executes. The fact that it's doing something completely inappropriate to what a LINQ query actually is, what a LINQ query actually means, is no concern of the compilers. The compiler assumes that if you put a method called where in there, you know what you're doing and that's what you want. So this transformation is really naive, it is really dumb. Unfortunately, that's a really good thing, and we'll see why a little bit later. It also explains why you may see the occasional rather odd-looking error. So if I remove that using statement, and build that, I'm now going to get some rather odd-looking errors. It now says I can't find implementation of the query pattern, and what that's basically saying is I can't translate this stuff into where methods. If we can actually get rid of some of these extraneous bits, we might be able to get an even more raw error. No. Depending on exactly where this happens, you may actually see an error saying, I can't find a method called where. And you go, but I didn't mention a method called where. And what's happened is that before the compiler actually checks for errors, it's done that dumb transformation, emitted effectively a .where call, and then it's passed on to the next stage, which says, well, now I've got this .where thing and I can't find anything appropriate because the extension methods in system.link are no longer in scope. It will only look for things where the namespace has been imported. The reason that the transformation has to be naive is because that allows normal method resolution to come into play. And that means that it can choose the appropriate method for whatever the variable is. So if the compiler had been smart and translated the where clause into a call to enumerable.where, which is the LINQ where method, then there'll be no way to make it core. There would be no way to translate where into other methods. Now, we've seen that translation of where on clothing, and that was pretty useless, but it's really valuable in other cases. If you saw the parallel extensions talk yesterday, you can see we've got a where clause in here, but we've got this as parallel thing. Now, as parallel returns a parallel query. And when I do let's just bring it up. There's a class called parallel enumerable, and that's got a where extension method. If we just hop to the definition of that, you can see that's defined on the parallel query object. So by naively omitting that .where syntax, it now means that any instance method or an appropriate extension method can be used. So rather than being hardwired to enumerable.where, the compiler, the next stage of compiler, can pick out the appropriate library, the appropriate extension method, the appropriate static class to use for resolving that .where method. And this also explains why these two queries are duplicated. So if we have a look here at these two queries, you'll see that the actual body of the queries is completely the same. We're applying the same where clause, the same order by clause, the same select clause, just to a different data source, babies versus babies.asParallel. Well, this does not look like my idea of code reuse. I've got the same query repeated twice. If you think that is okay, if you think that's good enough, let's look at the LINQ ray tracer example, where the query looks like this. And in the demo, which you can download from the Microsoft website, in that demo, that query, that entire insane query, is repeated twice. Why does it have to be that way? Why can't we just apply the query to different data sources? And the answer is because the compile time type of the argument is what causes the query to get resolved against enumerable versus parallel enumerable. If we just made this a query that took a source, this source, that would have to have a compile time type. And if that compile time type was IEnumerable, then you would get the enumerable methods. It's only because that compile time type is parallel query that the compiler chooses the parallel enumerable methods. So because we can't vary the compile time type of that thing, we have to have two copies of the query, because they're going to get resolved down to completely different sets of calls against completely different static classes. Does that make sense to people, why that's happening? I'm seeing a little bit of nodding. Are people not comfortable with that? Do we want to dive into that a little bit further and see what the compiler's doing underneath? Give me some feedback here, guys. Yes or no? Do we want to dive in more? Sorry? Yes, we do. Okay. I think the yeses were stronger, sorry. Okay, let's take a look. So let's jump in here. We've got all that. Yeah, you can go away. Right. Okay. I'm going to go ahead a little bit, and I'm going to bring in LINQ to SQL. People used LINQ to SQL? Pretty much? Yep. Okay. So here's a dead simple LINQ to SQL model. Come up faster, dude. There we go. It's really simple. So let me bring in a new data model. I'll get rid of that old one, and we can get rid of all of this stuff. Okay, so let's take a look at this function. So this data model is now a wildlife data context. It's got a where method. That penguins is a table of penguins. So let me try compiling that, and then we'll have a look at that in Reflector. And let's it's not going to show me the really underlying stuff. If I follow along to there, you can see that's actually called the where method in the, there we go, in the queryable class, because that table of T implements iQueryable of T. And so there's several extension methods in scope for that. It could match the where of iEnumerable, and it could match the where of iQueryable. But the where of iQueryable is a better match, so this compiler is going to choose that. On the other hand, if I change the compile time type of that, and now select from there. So you might think that's doing exactly the same thing, but because this where method is now going to resolve against an iEnumerable, it's going to end up choosing a different thing. So if I build that and we do a refresh, and let's have another look at this. If I now go and look at that, you'll notice this is a different overload, and it's in a different class. It's in the enumerable static class. So although it's the same underlying object, because it's a different compile time type, the compiler has done its overload resolution differently. Overload resolution is based on the compile time type, the type of the variable declaration, rather than the runtime type of the object. So even though at runtime, that P's variable is actually pointing to an iQueryable, at compile time, the compiler only knows it's an iEnumerable and will choose an overload that's appropriate to that iEnumerable. And there's nothing that we could do, there's no type that we could put there that would cause it to resolve to iQueryable, sorry, to queryable.where or enumerable.where based on the runtime type of the object. Overload resolution is always on the compile time type, with one exception. We talked, if those of you here at the C#4 talk on Monday, you remember C#'s got a dynamic keyword? So the dynamic keyword defers overload resolution until runtime. So you might think to yourself, aha, what I'll do is I'll make this dynamic, and then it will look at, and then it will figure out which extension method to use based on the type at runtime. Yeah? Not so happy. So if you think about it again, it's going to be very difficult for the compiler to choose an extension method based on the runtime type. For the runtime might choose an extension method, because there's all sorts of rules about, well, where should it look? Which assemblies should it look in? Maybe system.link hasn't been loaded yet. What namespaces were actually in scope when the code was compiled? We're only supposed to consider extension methods whose class had been included by using. So the compiler can't do, the runtime binder can't do that lookup. It has to be done at compile time. That means we can't use dynamic, and it means that we are very sensitive to compile time type. Does that clarify that to people? Excellent. Okay. So if I'm going too fast, I'm going too deep, then yell at me, make me slow down. Okay. So the other thing that this kind of begins to bring in is the fact that we kind of want to be able to look at handing methods off to an external provider. So this idea of we've got linked to objects, we've got a data model of penguins, we've got a list of penguins, we can enumerate over it, we can filter out all of these things. That's great, until we have a database with 60 million penguins in it. And at that point, we do not want to download 60 million penguins from the database and go looking for a small subset of those. That's incredibly wasteful. What we really want to do is have that query, that where clause, run on the database itself. So if we bring up SQL Profiler and have a look at what's going on here, this data model.penguins is now a LINQ table of penguins. And if I run that, you'll see that what's coming back there is now that's now the penguins we defined in our LINQ data context. If we look at SQL Profiler, what's happened? Well, this doesn't look so good. This doesn't look good at all because it's not respected my where clause. It's just gone and selected everything from the database. Why has it done that? It's because I left that as being an IEnumerable. And when we do an IEnumerable, when we've got an IEnumerable, all the compiler can do is go to enumerable.where, which will treat it as a bunch of objects, and we'll just iterate over it as objects. So although that data model.penguins is now pulling down data from the database, it's not considering the where clause as it does so. The pulling down is kind of happening at this level rather than at this level. If we get rid of that and use data model.penguins directly, this table T implements a different type or another type, which is somewhere over here, iQueryable of T entity. iQueryable of T entity or iQueryable of T derives from IEnumerable T. So anything that is queryable is enumerable. But enumerable makes the simple promise of, if you ask me for stuff, I will give it to you. I can give you a sequence of objects. iQueryable says, but I'm going to need my mate to help me. Let's have a look at what iQueryable actually contains. And it contains, this is one of the bits of magic, it contains this iQuery provider. So iQueryable has got an iQueryable thing has got a little helper class, an iQuery provider that can actually do the querying work for it. The iQueryable is still IEnumerable, it can still be iterated, but it's going to delegate the hard work to the provider. So what happens when we run this using the iQueryable? We saw earlier that that it would now resolve down to the queryable overload. And let's see what the impact of that is. We get the same result set back, but if we look at the SQL query that ran, you can see there is now a where clause in there. So how did that come to be? Again, if we bring up Reflector and take a look, just refresh that. So we've got the queryable version. It's because that's now gone to the iQueryable, and we'll have a little bit of a look later on about how this works, but basically that's doing some work to hand off to the provider. So instead of iterating over objects, it's handing the query, it's handing that where clause to the provider. The provider's going to figure out what to do with it. And that's what iQueryable does. And that's why that compile time thing, that compile time type, is so sensitive because of that different resolution. Do I hand it off to enumerable.where or queryable.where? Does that make sense to people so far? Is that okay? Excellent. What about that where operator? So where you can see here, let's spell this out a little bit more explicitly. So let's drop down to, let's get rid of that that smart compiler stuff. Let's write it out by hand. .penguins .where delegate penguin p. No, let's not do that. Let's show you the lambda form. P goes to p dot age greater than 10. Let's keep it nice and simple. Okay, so what we've got here is a delegate. Because we talked about lambdas earlier, they're just delegates, just a more compact form of that. So how does that delegate get sent to SQL Server? How do we serialize a delegate over the wire and get it to run on SQL Server? Well, that's a bit of a chin scratcher. Maybe it uses SQL CLR. Oh no, it works in SQL Server 2000. That didn't have SQL CLR. You couldn't run assemblies on SQL Server there. Plus, Entity Framework works with Oracle and SQLite and things like that. They don't run .NET, do they? And it can talk to the RM that I work on. We can talk to MySQL running on Linux. Linux can't run .NET in MySQL, can it? So how does this delegate get serialized over the wire? Well, if we actually spell this out as a delegate, we see that it doesn't. So let's try writing that out long form. And just bring that around so that you can see it a little bit better. So if I build that and run that under SQL Profiler, let's see what happens. There's a surprise. Our where clause has gone away again. Why does that happen? It's because of the different signatures of the where method. So let's take a look at how the compiler is resolving this stuff. So if we now look at this queryable.where extension method, that's not a delegate. This func of tsource and bool, that's a delegate, but this expression thing is not. Whereas if I look at enumerable.where, that is taking a delegate. So the compiler is looking at this where method. In fact, again, if we spell it out, then we may be able, well, no, we can't spell it because we're trying to show override resolution. The compiler is looking at this extension method and going, how can I resolve that? Well, I need an extension method whose first parameter is compatible with data model.penguins. So that means the first parameter has got to be an iQueryable of Penguin or something that is a base class of iQueryable of Penguin. Its second parameter has got to be a delegate. So the first thing it will go is, well, queryable looks like a great match because its first parameter is an iQueryable of Penguin. But then it looks at the second parameter and goes, no, that's not going to work. For my second parameter here, second parameter here, I need an expression. And you've not given me an expression. You've given me a delegate. So how can it be that when we put that delegate in lambda form, go faster. When we wrote this, it worked. Aren't they the same thing? They're not. And this is the deep secret, the deep magic of lambdas. If you think about the type inference thing we saw earlier, in type inference, the compiler would look at the right-hand side of an expression and work out what the type must be of the left-hand side of the expression. This is kind of going the other way. The compiler is looking at what you're returning it into, or what you're going to be putting it into, and deciding, I'm going to interpret that as an expression or a delegate, depending on where it's going. It gets compiled in two different ways. So if I compile that, and we'll have a look at it in Reflector, we'll just refresh that. Let's look at what's inside there. This is not a nice friendly delegate. This is an expression of lambda of func of penguin of bool containing an expression dot greater than of expression of property of expression dot parameter of type of penguin of method info of method of penguin dot get age. You can see it's compiled to something very, very different. And in fact, we can actually show that in a very explicit way. Let's have a look at this. So if we write func of penguin to bool f equals p goes to p dot age greater than 10, and then we can write expression. I can't write expression apparently. I know how to start, I just don't know how to stop. Now, it's not going to be able to work out the types from that. Sorry, yes, it is. We'll just have a func of penguin of bool. So here we've got two identical lambdas. absolutely identical source code. But once again, when we look at how that source code actually compiles, you can see one of them is compiled down to a delegate, an anonymous method. The other one is compiled into one of these horrible, chaotic expression-y things. And this is the deep magic of lambdas. They will be compiled into whatever is required, an expression or a delegate, depending on how they're being used. So when we come up here, the compiler sees I can use queryable.where if I decide to take this as an expression rather than a delegate. And because that can be an expression rather than a delegate, it gets the correct overload and everybody is happy and our SQL query runs efficiently. It chose that basically because it prefers expressions when it can. The iQueryable of T was a better match for queryable.where, and the expression is now compatible. So it basically thought, yeah, expressions are preferable because they mean that the work can be done somewhere else. Does that answer the question? The compiler decided that, yes. I can't control that. If I need to control that, I need to, again, put this sort of explicit typing in of creating a func or using an IEnumerable or something like that. Let's take an example of that. I'm glad you asked that question. Let's take an example of that, the expression horror class. That's what we want to start with. So here, for example, I've got, there's my sort of basic query, but I can actually spell out, here's an expression, that's going to build that expression, and I can actually feed that expression variable into my where clause. Now, I can also explicitly force that to be a func, and now that will end up being resolved as enumerable.where because it can no longer use the expression-oriented overload or the expression-oriented resolution. So again, by putting an explicit type in, by kind of changing the return type, I've changed the behavior of the query. So the question is, in future versions, might the rules change around resolution of the static methods? I guess the answer is that in the future anything is possible. It's kind of unlikely, and the reasons are twofold. Firstly, compatibility. If they were to change those resolution rules, then there'd be a huge potential for breaking stuff. Secondly, the architecture of queryables and expression trees actually provides a very high degree of extensibility, so that rather than extending things through changing the language and the compiler rules, things are more likely to change by people adding new providers, new implementations of queryable or iQuery provider. There should be very little need to change the resolution rules because iQueryable and iQuery provider provide the hook for you to change your own implementations already. Does that answer the question? Okay, sweet. We can, by the way, create expressions ourselves. And if you really want to make LINQ queries that will guarantee your job security, this is the correct way to do it. It will work. Believe it or not, it will actually work. Elderly Penguins 3, if we slap a SQL... Sorry. Oh, sorry, could you say again, please? If I may... Sorry, I'm terribly sorry, I can't hear clearly. Oh, sorry, okay. Elderly one a var. So, down, okay, there. That is an excellent question. Thank you very much. I'm glad you mentioned that. What do people reckon? How many people reckon delegate? How many people reckon delegate? It'll compile to a delegate? We've got 3 or 4 for delegate. How many people reckon it will compile to an expression tree? More. Somebody who hasn't put their hand up, what do you reckon? What are you thinking? Okay. All right, let's see what happens. You guys are all wrong. Doesn't compile because it doesn't know whether to compile it as a lambda or, sorry, as a delegate or an expression. Lambda syntax only makes sense, it can only understand how to compile it when it's been told this is going to be a func or this is going to be an expression. It's got to be given that context on the left-hand side or implicitly through the idea of it being passed into some function. Is that okay? Excellent. So I can actually build these expression trees. I didn't put a trace on that, did I? Let's start a new trace. We'll run through that. And you can see, even though I built that expression tree very explicitly, tell me that's been passed across. Yeah, there we go. It's been passed across as you'd expect. So, just to review that, the LINQ query syntax, that C# or Visual Basic built-in syntax, gets transformed naively to dot methods, dot where, dot select, dot order by. You can go and look at the list of standard query operators. Extension methods get resolved, and they'll almost always get resolved down to enumerable dot something or queryable dot something. Though we've seen in the parallel extension, if you've got that dot as parallel, they'll get resolved down to a parallel enumerable dot whatever. And you can potentially add your own static classes to do that, just as the parallel extension guys did. And the compiler then does a whole bunch of overload resolution and figures out, do I need to compile the various lambdas as delegates or as expressions? Does that all make sense? I can show you slides if that will make things easier. Or anyone want to see slides? Wow, you guys are hardcore. Okay, so this all sounds good. We've managed to compile one of these things. How does that actually get to run? What actually happens when one of these things executes? Well, obviously for the enumerable case, that's pretty easy. We can imagine it's got implementations like we saw in our enumerable helpers. There's a whole bunch of operators, but they're all pretty trivial. You could write LINQ to objects in an afternoon. Seriously, you could write LINQ to objects in an afternoon. They're pretty much all just for each or putting things into a list and doing a yield return or whatever. The actual implementations have got some slight optimizations in there to avoid creating new objects, avoid creating new enumerators, because these things are used generally once only. But really, what you're seeing there, that is the where method. That is enumerable.where. What about queryable? Because that's doing some pretty strange stuff. We've got these expression trees, but how do they actually get turned into stuff for SQL Server to process? Well, if we have a look at iQuery provider, which is what actually does the work, we'll see it's got basically two interesting methods on it: create query and execute. And each of these takes an expression. And the way that everything gets compiled, the compiler puts everything together into that expression, basically emitting code similar to what we saw in the expression horror class, and passes it to the query. So we can see that if we have a look in here, I think. Let's not put the breakpoint there, let's put it there. And let's run that up in the debugger. Oh, yeah, if I go type things in random places, it's not going to work. So let's run that up in the debugger. And let's take a look. So in my locals, I've got this penguins thing. Now that's got a visualization as a SQL query, which is because of the way that it's implemented. If I have a look inside here, though, then I can you can see that it's got this iQueryable.expression because it's a table thing. And let's have a look at that. And this has got a rather helpful debug view option. This is just a member that's provided so that you can actually look at these things in the debugger. So what's that? Thanks a lot. What, can people see that? Is that okay? You can see that that dot where has been translated into a dot call expression. So if I go and have a look in the docs, there's a thing called a method call expression, and that's what one of these things is. And it's got a member info of that where method, and its arguments are a constant, which is the table of penguins, and a lambda expression. We've heard the word lambda before. That's the thing that got compiled down to an expression. So what's in that lambda? A lambda is like or in this case, a lambda expression is like a description of a function. In this case, an anonymous function. And what is it? Well, it's a function from a penguin to a Boolean, which takes a penguin in and returns penguin.age greater than 10. Actually, that's still a little bit misleading because that looks like it's running code, and it's not. It's actually representing something like what we saw in the expression horror, wherever that's gone, which is a expression dot greater than or equal, taking a member access expression and the constant 10. So again, if we had a look at a reflector at what that query was, we'd see those all being built up. Okay, so that's what's in the expression object. Where does it all come from? How does it actually get in there? Well, part of it is just the different compilation steps. So we saw here, we've got that lambda in there, and we know now that that gets compiled in a different way. It gets compiled into expression factory methods for for member access greater than and constant. But the other thing we saw in there was that where call. There was a method call expression with the where method, and that's kind of weird because the where method isn't appearing inside the lambda expression. So how is that? That's just a function call. How is that being turned into an expression? And the answer is that the queryable implementations of something like where do two jobs. Firstly, they run as you would expect. You know, when that query gets executed, the where method runs. But what does the where method do when it runs? It creates a new query on the query provider with the expression being passed that query being a method call to itself, and with its arguments being the arguments that got passed in, the source expression, that source sequence, and the predicate expression, the criterion. So where is doing two jobs here? It is running, and in the process of running, it is quoting itself and passing itself into the expression, or passing a description of itself into the expression. Does that make sense? Well, we're getting worried here, aren't we? We don't like the idea of this. We don't like the idea of this. Okay, let's step back. So let's look at our expression horror again. We need to get something. We need to identify that predicate, that is elderly thing, needs to be associated with where. So, for example, that is elderly could appear in different places. It could be, for example, in a select clause. We could be selecting true or false for each penguin, according to whether it's elderly or not. So the LINQ builder, the LINQ compiler, needs, the LINQ builder needs some way to say this expression goes in a where clause, whereas this expression is going to go in a select clause, so that they can be translated to the right bits of the SQL query. Does that make sense? Okay. But the where and the select are just methods. They're not inside the lambda. They're not inside that pointy arrow thing. So they don't get to pretend to be expressions. They don't get to be compiled as expressions. They can only be compiled as method calls. Does that make sense? So when we come to that query, when we come to execute that query, those methods are going to run. They're not being quoted, they're actually being invoked. Yeah? No. A little bit hard to explain, I guess. Let's have another look at the source for this. So this iNumeral of penguin, data model.penguins.where. So that where is just a method call. This is just a library, nothing magic is happening. So when we hit a method call on an object as we're executing our program, what do? What happens when we hit a method call? We run it, yeah? We invoke it, we call that method. Good with that? Okay. So I know this is brain taxing stuff. I have commit logs around this that just say brain explodes. So where has got to run? It's not being quoted, it is being executed, yeah? The only thing that is being quoted and not executed is this expression.lambda stuff. And if we look at that, there is no where inside that expression.lambda. So something, we've agreed that we need to have a where associated with a lambda, but we also agreed that the where method is going to execute and be passed the lambda. So how does the where method get itself into the expression tree? Are we agreed that's the problem? Okay. So what happens, the only chance we've got to do something with that is when where runs. It's going to run, and that's our only opportunity to get it into the expression tree. Yeah? Okay, so what happens when where runs? Let's take a look at the where implementation. We do some error checking. That's boring. We don't want to check for errors. Okay, so what's the interesting bit? First of all, it goes off to the query provider, which is like the SQL statement builder. And it says, I want you to create a new query for me. And that query's got to have an expression associated with it. And I don't want you to use, naively, the expression that was passed into the where. I want that new query to have a method call expression for the where method. So that method, that dot call, is building a new expression which is quoting where. It is saying I have a method call expression, and the method that I'm referring to is where, the dot where method. Yep, is that okay? Now we also want to make sure we have the information that was passed into where is also being passed along with the where that is now being passed. And that's where these arguments come in, that source expression and the lambda predicate. So this, if you look at any of the queryable methods, they all have this same kind of pattern, this sort of jujitsu pattern, where they quote themselves, put themselves into a new query, and then bring in the things they're meant to be dealing with as their arguments. So when they execute, they transform themselves from invocations into method references. Does that make a bit more sense now? Is that beginning to come together? Okay, I'm seeing a few more nods. That's great, because we're pretty much out of time, so I'm glad we managed to sort that one out. I know this is a 400 level talk, guys, so there's no mercy in this talk. Okay, I just want to, I'll very briefly, I know you're keen to get to lunch, but very briefly just want to talk about how iQuery Provider actually processes the expression object. So we've seen that iQuery Provider has got a, let's get rid of that, we don't want PowerPoint. We've seen that iQuery Provider has got an execute method. What actually happens in that execute method? Well, I don't have access to the internals of LINQ to SQL, but I do have a LINQ provider that I wrote earlier about what's this? No, but JD's gone home, so it's not like we're being broadcast to the whole of TechEd or anything like that. Anyway, this is the version 2.1. You need to upgrade to version 3. So what actually happens when a LINQ expression gets passed in? So now we've actually got an expression tree. We can actually walk over that expression tree, we can iterate over that tree recursively down that chain of dot calls and dot greater thans and dot constants and so on. We can look at the elements of that tree and we can figure out what to do with them. And what you end up with is basically a big honking switch statement. You know, so much for your fancy virtual methods. Ha ha ha. We're just going to look at the different types and process them in different ways. And the way that they're processed is it's unfortunately pretty complicated, and it will be highly dependent on what they're doing. But basically, the strategy is going to be derive a class from expression visitor, and as it chunters through, it will basically look at the different kinds of expressions. So here, for example, in Lightspeed, if we see a method call, then we're going to translate. We're going to pass that off to another class to translate. When we see binaries coming in again, we'll look at can we translate the binary operator. And that's how things like, for example, you saw that dot starts with method on a string. Well, you can't use a dot starts with on a SQL varchar. There's no such function. But if you looked at that profiler trace, you can see it translated into a like operator. So that's going through something like, and again, this is just how we do it in our implementation, is we've got a bunch of things. So we say if you see a method call starts with, it's going to get translated into a like method with the appropriate expression being built up. Again, don't worry about the details. This is kind of, we're getting into internals now very much, but that's the kind of smarts that are going on. You can in fact extend that using the function attribute. So for example, where are we? If we just take this, if I want, for example, to find things by sound, and I'm not too concerned about whether it's correct or not, then I can use the SQL Server difference method, which is SoundX implementation. But the problem is, I can't call something like a dot similarity or a dot difference method on a string, because LINQ is type safe, and LINQ will go, there is no difference method on the CLR string type. What I can do, though, is I can create my own method, similarity, that takes a string or pair of strings and maps them to the SQL difference function. Now, look at the implementation of similarity. Look what it does. That's not going to work, is it? That's going to if I ever invoke it, if that ever runs, it's going to throw, yeah? So it's doomed. But actually, we might just get lucky. Not with the way my demos are going. Let's have a look. Where did I put this? So here we go. Penguins that sound like poop decks. That's always a useful thing to know. Let's not do that. Yeah, let's do that. Have I brought everything in? I have. Okay, so let's run that. And you can see, well, look, it has actually emitted that method. It's not thrown. Why is it not thrown? Because we never invoked it. It only appeared inside lambda expressions. And when a function appears inside a lambda expression, it is not invoked, it is quoted. An expression.call is emitted, like an expression.greater than was emitted. So it's never invoked. Welcome to the wacky world of LINQ, where throw is a perfectly satisfactory implementation for a function. All you're going to do, I mean, we couldn't put a right implementation. All that LINQ ever can do is name that function and throw it over the wall to SQL Server to be, or translate it and throw it over the wall to SQL Server. It never gets run. Unlike, say, the where method, which got run and emitted an expression as part of being run. Different LINQ variables can, so we've seen that in this case, we're using a table T. That's got an iQuery provider that knows how, basically it contains a link to SQL, it knows how to talk to SQL Server. Because the iQuery provider is a property on the class, different classes can have different query providers. So a Lightspeed query has got a query provider that we wrote. A link to SQL table has got a query provider that Matt Warren wrote. A entity framework, entity set, or whatever they're called, has got a query provider that the entity framework team wrote. If you use LINQ to nhibernate, then when you use the LINQ expression on an nhibernate class, it will go over to the nhibernate provider. So this is where that extensibility thing comes in that we were talking about earlier. The fact that we probably don't need to be putting more kinds of static class, more kinds of overloads onto this. Because if we've got something that's deferred, we can just have it handled through the iQuery provider extensibility point rather than through needing new resolution rules. Okay, so we've run out of time. I'm afraid we overrun by a little tiny bit, and I apologise for that. I hope it's been interesting. I hope it's been entertaining. I hope you've got a bit more of an appreciation, a bit more understanding of what's going on inside LINQ. I know this has been pretty tough, pretty mind-bending. That's what you get for coming for a 400 level session. I hope it's been fun. Thank you very much for your time.